This section is 5.6, Trapezoids and Kites. We're going to specifically talk about isosceles trapezoids in this lesson. So if a quadrilateral is an isosceles trapezoid, then each pair, notice it says each pair, of base angles is congruent. So a lot of times when we think base angles, we're thinking the bottom two. But with a trapezoid, we consider the top two base angles also congruent. So what it says is if TRAP is an isosceles trapezoid with bases RA and TP, then angle T is congruent to angle P because they're base angles. But also, angle R is congruent to angle A. So maybe if I color there, you'll be able to tell that they're separate. So angle R is congruent to angle A. There are two sets of base angles. Again, if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So if trapezoid ABCD is an isosceles trapezoid, then segment AC is congruent to segment BD. Unlike parallelograms, where the diagonals are bisecting each other, with isosceles trapezoids, the diagonals don't bisect each other. So if you look here, they clearly don't cut each other in half. But what they are is congruent. So with isosceles trapezoids, diagonals are congruent. I would pause this and write this into your notes. So using those first two slides of notes, CDEF is an isosceles trapezoid, and the measure of angle C equals 65. What are the measures of angle D, E, and F? Okay, so if we take the fact that base angles are congruent, that means 65 is also the measure of angle F, because angle C and angle F are base angles. Angle D and angle E are also the same, but it doesn't necessarily mean they're going to be the same as the other two base angles. So there are a couple ways you could do this. One, you could know that a four-sided figure adds up to 360 degrees. So 65 plus 65 is going to give me 130 degrees. So if I do 360 minus 130, I'll get 230 degrees. If I cut 230 degrees in half, I'm going to get 115 degrees. Why would I cut that in half? The top two angles are 230 together, and I also know they're the same. So if I cut that in half, that would mean this is 115 degrees, and angle E is 115 degrees. This time, trapezoid PQRS is isosceles. They tell us the measure of angle R is 106. What are the measure of angles P, Q, and S? So this is done the exact same way. However, I'm going to show you a different way to find the other angle. So I know right away that angle S is 106 degrees. Well, I see that on a trapezoid, you've got a set of parallel sides. So if you remember back to Math 1, when you have a transversal cutting through two parallel lines, their same side interior angles are supplementary. So if you notice here, we've got same side interior angles that are inside parallel lines. So that would mean whatever angle Q is supplementary to 106. So I know that supplementary means 180. So 180 minus 106 is going to give me 74 degrees. So I know right away that angle Q is 74 degrees, which also means angle P is 74 degrees. Finding angle measures in isosceles trapezoids. So here's an application problem. The second ring of the paper fan shown consists of 20 congruent isosceles trapezoids that appear to form circles. What are the measures of the base angles of these trapezoids? So we want to take this and let's blow it up. Let's make it bigger. So we've got this isosceles trapezoid in the bottom. I'll highlight that real quick. So we're just looking at this right here, but we're going to use information above it. We're trying to find the base angles. Notice that angle X is a base angle. You might be thinking that the other base angle is not listed. Well, remember the top two angles are also base angles. So we're just needing to find X and Y. So 18 degrees is the central angle up here. So that would mean I'm going to try to find X first. I know that, let me change my ink color here. I know that a triangle adds up to 180 and that my base angles of an isosceles trapezoid are the same. So I know that has to be x. Up here has to be y. But if I look at it this way and then I ignore y, I know this is 18, x, and x. If a triangle adds up to 180, I'm going to subtract 18, and I'm going to get 162 degrees. Since both of them added together equal 162, I'm going to take 162 and cut it in half. And I'm going to get 81 degrees. So I know x is 81 degrees. Now I need to find y. So maybe I draw the isosceles trapezoid here. I put 81 degrees in both of my base angles. So I'm trying to find the base angles up top. And remember from the previous slide, you could do the fact that same side interior angles are supplementary, or you could figure out the difference in 360. I'm going to go ahead and do the supplementary thing. So I know that angle y is supplementary to 81 degrees. So 180 minus 81 is going to give me 99 degrees. So angle y is 99 degrees. Moving on to mid-segments of an isosceles trapezoid. So if you know a quadrilateral is a trapezoid, or yes, it doesn't necessarily mean it's isosceles. If you know, though, that here, let me erase this because this doesn't even really matter. If a quadrilateral is a trapezoid, then first, the midsegment is parallel to the bases, and two, the length of the midsegment is half the sum of the lengths of the bases. So here's an example, a visual example. If trapezoid TRAP is a trapezoid with midsegment MN, first of all, if it's a midsegment, you notice here these markings, that means it cuts both sides in half. So TM is the same as RM, and AN is congruent to PN. That means that the line in the middle cuts both sides in half, so it's considered a midsegment. So if you have a midsegment, then two things are happening. MN is parallel to the bases, so that means it's parallel to RA, and it's also parallel to TP. It also means that MN is half the measure of the top base and the bottom base added together. So using that, we've got an example. QR is the midsegment of trapezoid LMNP. I could go ahead and put these markings here, but in this problem, we're not going to need those. I'm going to use the fact that I know the midsegment is half the measure of the bases combined. So my top base is 4x minus 10. I'm going to add my bottom base to it. So those are my top and bottom bases added together. My midsegment is half of that. So I'm going to go ahead and cut this in half and set it equal to my midsegment. That way I have an equation now that I can solve for x. I don't like fractions, so I want to get rid of this fraction first. I'm going to multiply both sides by 2. When I multiply an expression, make sure it's in parentheses so you distribute. These 2's go away. And I've got 4x, I'm going to combine like terms, minus 2 equals, when I use distributive property, 2x plus 4. Now it becomes a linear equation. 2x minus 2 equals 4. Add 2. 2x equals 6. X equals 3. One way you can verify your work, well, I can't plug x into this bottom base, but if I plug it into this midsegment, 3 plus 2 is 5. And then if I plug it in at the top, 4 times 3 is 12, minus 2 is 2. So is 8 plus 2 double what your midsegment is? So that equals 10. If my midsegment is 5, then it is half the measure of your bases added together. So pause the video, you do the work on this, and then press play when you have your answer ready to go and you can see my answer and compare. So check your work with mine. I got x equals 6 and mn equals 23. Last thing, last shape. Kites. If a quadrilateral is a kite, then its diagonals are perpendicular. First, let's discuss what a kite is. Notice a kite has 4 sides, and it also has consecutive congruent sides. So there are 2 sets of consecutive congruent sides. If I use my highlighter again, BA and DA are in a row, so that's consecutive, and those are both congruent. And then if you look at the other two, change my color. DC and BC are also consecutive congruent sides. They are not opposites, so on a kite, your congruent sides are not opposite. If you know you have a kite, then segment AC is perpendicular to segment BD. So AC is perpendicular to BD. When you have perpendicular lines, they create 90-degree angles. All right, quadrilateral DEFG is a kite. What are the measures of angles 1, 2, and 3? So right away, the first measure I know, let's not use yellow, you can't see that. The first measure I know is the measure of angle 1. Since this is a kite, they tell us it's a kite, I know my diagonals are perpendicular, therefore angle 1 has to be 90 degrees. They tell me the angle up here, angle GDF, is 52 degrees. So if I redraw this mini triangle, I know that's 90, I know that's 52. So I'm able to figure out what angle 2 is just based off of the fact that a triangle adds up to 180. So 180 minus 90 minus 52 will tell us what our angle measure is, and it's going to be 38 degrees. Okay, so we've got the measure of angle 2 down. Measure of angle 3 is a little trickier. You kind of have to use your knowledge from Math 1 and congruent triangles. So if I'm looking at these, if I'm looking at this kite, but noticing that it's just a bunch of tiny triangles, this is a right triangle, and on the right side is a right triangle. Since it's a kite, I know that ED is congruent to GD, and that this piece is congruent to itself. If you remember the postulate that proves triangles congruent, HL, that means hypotenuse leg. If they have a congruent hypotenuse and they have a congruent leg, then two right triangles are also congruent. That being said, then I know that the measure of angle 3 has to also be 52 degrees because these two triangles are identical. Okay, pause the video. You find the measures of angle 1, 2, and 3 on your own, and then press play once you've got it and see if your answer matches up with mine. So for measure of angle 1, I automatically know it's 90 degrees because diagonals of a kite are perpendicular. For measure of angle 3, we're going to skip 2 for a second. I know the measure of angle 3 is 36 degrees because these two triangles are congruent. So 36 degrees is also the measure of angle 3. Then I went ahead, and to find the measure of angle 2, I first calculated, okay, 90 plus 36 plus what would give me 180. So I know this angle right here is 54, which means that the measure of angle 2, which is its corresponding angle and the other congruent triangle, has to also be 54 degrees.